Hello, in this video I'm going to show a very simple circuit to detect if there's any current flowing through any mains cable. In other words, to detect if a mains device is on or off. So the circuit uses only a few capacitors, an inductor, a few resistors, 3 op amps and a diode, and that's it. So most countries use either 50 or 60 Hz for their mains power. A lot of countries in Europe use 50 Hz, but like the United States and Canada use 60 Hz. For this one, I'm using 50 Hz. So this here is an RLC circuit, and it's tuned to resonate at 50 Hz. So the way this circuit detects current flowing through a mains cable is by picking up the electromagnetic field generated by the current flowing through the cable. So if this is the mains cable, you've got current flowing through it that also generates an electromagnetic field around it. This coil from the RLC circuit, just a 10 millihenry inductor, picks up that electromagnetic field. This induces a current which flows through the RLC circuit, and across the resistor like you get a voltage generated. So like this signal we're picking up here is an AC signal, and it's very small, in the order of tens of millivolts, maybe 20 or 30 millivolts. So we need to amplify this before we do anything else. So the next step is to feed this into this configuration of op amps, which is known as an instrumentation amplifier. So the reason for using 3 op amps and not just one is because of the signal is so small and it's weak in general. We just want to use an amplifier with a very high input impedance. So this configuration of op amps gives us that. So so this, you put the top left op amp up the ground because we want to feed our signal into, this is the non-inverting part of the op amp, and this will feed into the non-inverting part of the final stage, so the signal we get out won't be inverted. So the signal we get out is seen here. So it's rectified. It's rectified AC. So the reason why you've got these flat parts here is because whenever the input AC signal goes low, the op amp just can't do it because it's only got a 5 volt supply, so it just hits off the bottom rail, which is 0 volts. So and this actual amplifier is you set the gain. Well, this part of the amplifier stage here is just a gain of 1, and then the gain can be set in using just final op amp, like just a normal differential amplifier. It's set using these 2 resistors, and this gain is set to around 250. So like a 10 or 20 millivolt input will give us an output of around or about 5 volts. So yeah, again, this is the output we're getting, quite bumpy, and this line I've drawn on top, that's the output of the peak detector circuit here. So the general kind of the end idea of this is to feed the output into the analog channel of a microcontroller. But if we feed in this kind of bumpy DC, I mean, you could do that in software to find the peak of the curves there, to see whether, I mean, if the curves have high amplitude, that'll mean the device is turned on, there's current flowing, and if it's low, that means it's turned off. But it's a lot easier if you just add in 2 extra components and you get an almost straight line. It's easier to do when writing the code for the microcontroller. So that's pretty much it. I'll just show you how the circuit works now. Okay, so here's the circuit. It's a bit messy, but it'll do for now. So over here we have the op amp. Actually, that's an LM324. There's 4 op amps in there. I'm using 3 of them for the instrumentation amplifier. The capacitor you see here, and there's a diode. That's the peak detector circuit. Then up here there's a microcontroller. And over here we have the RLC circuit, and it's just a capacitor, an inductor, sorry, let me just readjust, and a resistor. And over here we have a mains cable attached to a lamp. Alright, So first I'll just show it working, give me a sec. Okay, so the inductor is right beside the mains cable, and over here I have an LED, and so the microcontroller, that orange wire is connected to the output of the peak detector. It's going into the analog channel of the microcontroller, and it just has two lines of code. If the analog value goes above a certain value, turn the light on, the LED on. Okay, so just turn the light on, lights on, LED comes on, lights off, LED goes off, on. Oh, sorry, I moved the cable away. On, off, on, off, on, off, on, off. So that's pretty cool. So yeah, I just thought I'd give a quick look at the voltages that's coming out. So just going back to the actual diagram, if we look at the output of this RLC circuit, I have that up on the scope here now. So you can see that on the scope there, and the lamp is now off. When I turn the lamp on, it goes up. So it's 42 millivolts max value, and it goes down to half that effectively. So that's quite cool. It's a big change. So now I'll show you the output of the op-amp stage. Just give me 1 second. Uh-oh. Okay. So now I just need to change. Okay. So, actually, hang on. I'll show the output of the actual op-amp first. So this is the output of the op-amp on a 2-volt scale. So the lamp is off at the moment, and it's around, I think that's the max there is jumping up. So just from looking at the scale, it's around 2.5, 3 volts. Okay, so now I'll turn the lamp on. Just give me a second. Yeah, turn the lamp on, and it jumps up to around 4.5 volts. So again, we don't really want to feed this straight into the analog channel of the microcontroller. It's kind of a pain to work with. So then you just put that through the peak detector. So I'll show you the output of the peak detector now. Again, so what I just showed you, first I showed that, then I just showed the output here, and that's quite spiky all over the place. So now I'm going to show you the output here, and this is the one that we feed into the microcontroller. So there we go, back to the scope. So there's the output, the lamp's off. What value is that? It's like a few hundred millivolts, sorry my hand's shaking. And turn the lamp on, and it jumps up to around 2.6 volts. So it's quite a big change. Feed that into the analog channel, 2 lines of code, job done. Off, on, off. So yeah, that's pretty much it. Thanks for watching.